This tutorial is about using formula involving 2 alpha. So you've got two different types. You've got sine 2 alpha or cos 2 alpha. And sine 2 alpha expands only one way, and it's basically 2 sine alpha cos alpha. But cos 2 alpha can expand 3 different ways. And this is the tricky one because you've got to use whichever one is best for the question that you're doing. Okay, so sometimes you might not need to use this one, and this one's a better one, and so on. So you never know which one to use here until you see the question. So here's a little example. It says find the exact value of 2 cos squared 15 degrees minus 1. Now if you look at the layout of this, it looks the same as this one here. So we want to rewrite this back into this form. So we could write down cos 2, now alpha is whatever the degrees is in there. So in this case it's 15 degrees, so I'm going to write times by 15, put little brackets around that. Notice everything else is the same, the 2 is the same, and the minus 1 is the same, so you're just going to end up with cos of 30 degrees. And the exact value of cos of 30 degrees is going to be the root of root 3 over 2. Can't see any of that there. There we go. So the cos is, so there we go, cos of 30, which is root 3 over 2. Okay, you could get something a little bit more challenging. They might ask you to show, let's go example 2. Show sine 3 theta equals 3 sine theta minus 4 sine squared theta. Oh, so it's not sine squared, it's sine cubed. Okay, so again, you want to take one of these sides to try and prove this, and the best side to use would be, I think, to use this one here. So I'm going to start with the left-hand side. So another way of writing sine 3 theta is to write it out as sine 2 theta plus theta. Okay, now I can't use one of the formulas we were given on the previous page because they were all to do with sine 2 theta, but if I change it like this, I can now see that I've got my 2 theta here, and this means I will be able to use one of those previous formulas. Now again, this here, hopefully you'll recognize that as the addition formula, so we can expand this out using the first addition formula, which was sine 2 theta cos theta plus sine theta cos 2 theta. Okay, now I'm going to move this right across to the start here because the next expansion is going to become pretty hectic. So sine 2 theta, there's my double angle formula for the 2 alpha formula. And if I look back, I can rewrite this sine or sine 2 alpha or sine 2 theta like this. Okay. So I'm going to rewrite this as 2 sine theta cos theta. And I'm going to put brackets around that, and I've got to still multiply by this cos theta here. So that cos theta could be over here if you wanted it on this side of the bracket, but I've got to basically multiply that times that at some point. And then we've got sine theta. Now we've got to expand this. Now we have got a choice of 3 different expansions for this. Now if you look at up at the question, it asks us to have it in this form, and it's got a sine cubed theta here, which means more than likely if we used this one here, we're going to get a cos squared theta and also a sine squared theta or alpha. If we use this one, we'll get a cos squared theta, and this one here we'd get a sine squared theta. Okay, so that would be the most likely one I'd think of using this now, because if I multiply that by another sine, I would end up having a sine cubed theta. So I'm going to try it with this one first of all and see what happens. So I'm going to rewrite this out. That is going to become 1 minus 2 sine squared theta. So that's me expanding out the cos 2 theta in this form. Okay, let's try and multiply some of this together. So we've got this times this is going to give us 2 sine theta cos squared theta plus that times that is going to give us sine theta, and then this times this will give us minus 2 sine cubed theta. Okay, so we've got a problem here with this cos squared because we wanted to have a we don't want a cos squared in there. We want to have well, we don't want any cos squared in there because if you look at the question, it's got sine theta and it's got sine cubed theta. So we've got to try and get rid of this somehow. Now, if you remember back to the days of Int 2, you were told that sine squared theta plus cos squared theta equals 1, which means we can rewrite that as cos squared theta is equal to 1 minus sine squared theta. So we can use this here to replace that cos squared theta and get it in terms of sine squared theta. So we can go 2 sine theta. The cos squared theta has been replaced by this part here, so we put in brackets 1 minus sine squared theta plus sine theta minus 2 sine cubed theta. Okay, so all the rest of that is staying the same. We just have to replace that cos squared theta there. Okay, again, multiply out the brackets, so I end up with 2 sine theta times 1 is 2 sine theta. 2 sine theta times negative sine squared theta is going to be 2 sine cubed theta plus your sine theta here, and then take out minus your sine cubed theta. And we're almost there now. We've got look at that, minus 2 sine cubed theta minus 2 sine cubed theta, and that is going to be our, where's it gone? Our minus 4 sine cubed theta there. And also sine theta plus another sine theta is 3 sine theta, and that is exactly the same as what we started off with. So therefore that's the same as the right hand side, so therefore proving that sine 3 theta is exactly the same as this. Okay, I hope that helps you with some double angle formulas.